are going to see the editorial of LeetCode question number 287, where we have to find the duplicate number. So if I will talk about the question, you can see the question here, in which it is given that we have n plus 1 elements and all the elements are in the range of 1 to n. And main important for this question is, if you will see this point, all the integers in nums appears only once except for one integer which appears two or more than one time. So let's see the approach to solve this question. First, I will explain you what is the sample input and sample output. So let's take some of the examples. Suppose I can take it as 1, 2, 3, 3, 3. This also I can take because we know that n value is equal to 5 and all the elements are in the range from 1 to n only. So it is correct. So here my answer will be 3. Or I can take the example as 4, 4, 4, 4, 4. Here n value is 5 and we can see that all the elements are in the range 1 to 5, which is 4 only. So our answer will be 4. So many of we misunderstood the question as only one number can be repeated. No, that's not the correct here. A number can be repeated more than 2 times also, but it is sure that only one number will get repeated. It cannot be sample input cannot be like 1 2 2 and 3 3. Here two numbers are repeated. This is not the input format for this question. Only one number will be repeated and it may repeat more than one time and its range will be from 1 to n only. So I hope this question is clear for you all. And there are many solutions to solve this problem, and if you will read this question, according to question, we have to solve this question without modifying the array and in constant space. This is the given in the question, which makes this question harder. So if we will ignore this for some time, this condition, and if we will talk about brute force solution, so let's talk about first method. So every method I will explain using example, so that will be good. Let's talk about the first example. Let's take a array as 1 3 4 2 2. So what we can do is we can apply directly brute force here. If we will apply brute force, what we will do, we will take 1, we will search in this entire space. We will take 3, we will search in this entire space. We will take 4, we will search here. We will take 2 and we will search here, and we see that here we found this 2 again. So anywhere we found the 2 again, so what the element we are finding, that is our answer. So for this, can I say that it will be nothing but nested loop. It will be a nested loop and time complexity will be n square. So if my time complexity is n square and given constraint is n is 10 power 5, so n square will be 10 power 10, which will leads to TLE. So this solution will not work. So let's come back to the second approach. How we can solve the second approach, or how we can optimize this. So if I will talk about second approach on the same example, if I will take a set data structure. So what is the use of set data structure? It will not allow the duplicate values. Suppose this is my set data structure where I am storing the values. First I will get 1. If I will get 1, if it is not there in this set, I will add. I will write here not there means add. I will add 3 also. 4 I will search in this set, not there. I will add 4. 2 is not there. I will add 2. Again when I will get this 2, I will see that it is already present in this set. So if it is already present, so this 2 is our answer. Now, if we will talk about time complexity for this case, if you will see, we have iterated only one time on this array. So time complexity will be big O of n, and the space complexity will be also big O of n, because we are using a set space here. So what was our method 2? Method 2 was simple. We will iterate on each and every element. If it is not there, we will add in this set. If it is already present, that is our answer. And after getting the answer, we will break from here. We will not search more further. So now let's talk about method 3. Method 3 is nothing but like frequency array. So we will use a frequency array here. Now what we can do here is we can take 1, 3, 4, 2, 2. For each element we will map its frequency. So 1 frequency 1, 3 frequency is 1, 4 frequency is 1, 2 frequency is 1 now. Again when this 2 will come, its frequency is getting bigger than 1. So whosever element's frequency is getting bigger than 1, I will break and say that this is my answer. So here also time complexity is big O of n, because we are iterating on the entire array, and the space complexity is also big O of 1, because we are using a map space. So these are the small, these all solutions will get accepted, but according to question, we have to make this as big O of 1. So this was our method 3. Now let's talk about method 4. I hope you all will able to code using this approach, because these are simple set and map operations. Now let's talk about method 4. So method 4 is pretty, means we can use bitwise operators here. I will not explain this in detail. I will make a particular video on this, but here I will not discuss in detail. I will just give you the rough idea of this. Suppose given number is 1, 3, 4, 2, 2, and value is 5. Now what we can do is we can XOR this 1 to 5, means that we will XOR all these elements, and all these elements and 1 to 5 also. So property of XOR is 2 XOR 2 is equal to 0, means that A XOR A is equal to 0. It cancels out. So 1 1 will get cancelled out, 2 2, 3 3, 4 4 will get XOR cancelled out, and we will get 2 XOR 5. Now if we will get 2 XOR 5, we know that in this one number is present, which is our answer. We have to extract this answer only. So you can explore on your own how to extract this. I will make a particular video for this method. So now let's move to method number 5. Method number 5 is pretty simple. We can make use of Boolean array. We can make use of Boolean array, or you can take integer array also, or anything, no problem in that. So this suppose is our Boolean array, and this is the given array. Let's take same example again, 1 3 4 2 2. So this is our given array. So we will define a Boolean array of size 5 only. Now what we will do is, when we will get 1, so by default everything will be false. Now when we will get 1, we will make this true. We will get 3, next element is 3, so we will go to index 3 and we will make this true. We will get 4, we will go to index 4 and make this true. Now we will get this 2. So when we will get this 2, we will go here and make this true. Now when we will get this 2 again, when we will go there, we will see that the value is already true. So if value is already true, then that value is our answer. We got our answer. So I hope this method is clear to everyone. If it is false, if false, mark it as true, else that is our answer. So it is simple array operation which we can do. If we will say about the time complexity and the space complexity for this code, time complexity will be again big O of n because we are iterating on the entire array, and the space complexity is also big O of n because we are defining a Boolean array. Now these are the small approaches which we can use here, and if you will code all these approaches, then your basic will be clear in the coding. Now let's talk about method 5, and method 5 is little bit interesting also. Sorry, method 6. So let's take the same array again, 1 3 4 2 2. So this is our array. Now understand this very carefully. We are going to modify the given array. We are going to modify the given array only. Now what we can do is, first I will get 1. We will always take the absolute value. So we will get this 1. What we will do is, for 1, index will be 0. So what we are doing is, we are iterating on this for int ele in nums array. Let's take array name is nums. So what we are doing is, so we are finding its index. What will be its index? Index will be absolute value of ele minus 1. Why I am taking this absolute value, you will get this later. So what is absolute value of 1? It is 0, 1, and minus 1 will be 0. So we will go to index 0, and whatever the value is there, we will make this negative. So what we are doing here is, we are going to this index, and whatever the value is there at this index, whatever the value is there at this index, we are making this negative. Now before making this negative, there is some case also which we will understand later. So I am just keeping this down, the operations which we are doing now. Now again we will get 3. So for 3 we have to go to index 2. So we will go to index 2, and whatever the value is there, we will mark that as negative. Now we will get 4. That's why I told you to take the absolute value, because it is minus 4 when you will come here. So if we will take absolute value, then it will not create a problem. So for 4, what is the index? 3. We will go here and we will mark this negative. Now again we will take absolute value of 2 minus 1, which is index 1. We will go to this index and we will mark this negative. Now if we will come to this 2, for this 2 we have to go to which index? We have to go to index 1, but index 1 is already negative. So if index 1 is already negative, means that there was one number which marked it negative. The number which is coming now is repeated number. So from this I will get my answer. So we will only apply this condition if nums at this index is greater than 0, then only we will apply this condition, else our answer will be this present ele. So this 2 is my answer now, and we will break from here. You can break or return from here. I am just writing the rough code here. So in this way our time complexity will be big O of n because we are iterating on this, but space complexity will be big O of 1 because we are not using any extra space, but we are only modifying the given array. Now, I think this approach is clear to you all because we are taking absolute value -1. We are going to that index and marking it negative, and if it is already marked negative, there was one element which marked it negative previously, so my current element is my answer. Simple approach. Now, in this we are modifying our current array only, so that is also not allowed to do. Now let's talk about method 7. If we will talk about method 7, it is based on binary search. Now, if you will say array is not sorted, so if array is not sorted, then how we can apply binary search? So, we can apply binary search here. Suppose first I will give you the rough idea how this binary search will work. Now, suppose given array is, if we will take the same array 3, 1, 4, 2, 2. Now, let's take one number. So, before diving into binary search, it is important to know how my mid values will move and what we have to do. Now, let's take one number, start with 1, because we know that all the numbers are from 1 to n only, right? So, we will take 1 here. So, if we will take 1 here, then what we can do here? So, how many elements are less than 1, less than or equal to 1? We will count here. So, we will count here how many elements are less than equal to 1, which is 1 only, which is correct. Very good. We will take 2 here. When we will take 2 here, we will search here how many elements are less than equal to 2. So, if we will count here, we will get 1, 2, 3. But it is not possible because we know that there is some number which is repeating here, because from 1 to 2 there must be only 2 numbers, but we are getting count as 3. So if we are getting count as 3, 1 was correct, we are getting wrong answer on 2, because so can I say that 2 is only repeated. So let's take one more example. Let's take 3, 4, 1, 4, 5, 2. Let's do this on this. So here we know that answer will be 4. Now let's start from 1. So how many numbers are less than equal to 1? If we have to write this function, so can I write this as public int count? What we have to count? In this given array, we have to count from my, let's name this as 1 to n, let's name this as mid value. So when we will use in binary search, we will use the same function, then it will be useful. So let's name this as int mid. So here we will take one count variable and we will search in this element, right? Search in this array for int ele in nums. If my ele is greater than less than equal to mid, we will do C++ and at last we will return C. Now this is the function which will allow us to count total how many elements are less than equal to 1. Let's see here now. From 1 total how many elements are smaller? There is only 1, so we will take 1. Now we will take 2 here because 1 is already satisfied, right? So 1 cannot be our answer, so we are moving on the right side, means for the greater side we are moving. So mark this point, if answer is already satisfied, we are moving on the right side. Now let's count for 2. What is the count for 2? 1, 2. So 2 elements are less than equal to 2. Again count is satisfied, so we will move to the right side, which is 3. Now how many elements are smaller or equal to 3? Total 3 elements. So again count is satisfied, because we know that from 1 to 3 there must be only 3 numbers, and there is only 3 numbers, so no numbers are repeated. Now let's take 4 here. If we will take 4 here, now let's count for 4. 1, 2, 3, 4, 5. Count is getting as 5, right? So but from 1 to 4 we know that only 4 numbers must be there, right? But we are getting count as 4. Sorry, we are getting count as 5. We know that if 3 was already satisfied, when we included 4, it is causing one extra element. So can I say that this 4 is only repeated, right? So by this we can say our answer. Now if you will go for the 5, if you will count for this 5, let's see, means we know that we got our answer here. Not just count for the 5. Total how many elements we will get? 1, 2, 3, 4, 5, 6. We will get total 6 element, because one count was already increased here, right? So in this case what we have to do? We have to go to the left side. Is that clear? When my answer is satisfied, we are moving to right side, and when answer is not satisfied, it is bigger in size, we are going to left side. Now iterate on the same question using binary search. Now we are going linearly 1, 2, 3, 4 like that, and we are stopping at 4. Now do this using binary search. We will take the same example 3, 1, 4, 3, 4, 1, 4, 5, 2. So let's write the indexes. So we know that what we can do is we can take 1, 2, 3, 4, 5. Okay. Let's take mid value, left value, we have to take right value, so let's take left, right and mid value. So what is the left value we have to take? Left value we have to take is 1, because it's starting from 1, because we have from 1 to n. So what will be my right value? What is the size of this array? Size of this array is 6, but we know that there will be only 5 elements, so right value we will take n minus 1, which is nothing but 5. Now what is mid value of 1 and 5? Mid value of 1 and 5 is 3. So if mid value is 3, we will check the count. Total how many elements are there which is less than equal to 3. We will call this function here to count it. Now answer we will get as 3. 1, 2, 3. This 3 we will get the answer. Okay. So when it is satisfied, this count is satisfied, then which side we have to move? Which side we have to move? We have to move on the right side. So how we can move on the right side? Means now our mid was 3, so can I say that up to 3 my answer is already satisfied, so no need to check from 1 to 3. So if count is satisfied for 3 also, count will be satisfied for 1 also, and count will be satisfied for 2 also. So can I say that if we have to move on the right side, so my left value will be mid plus 1, which will become 4. Right value will be 5. Now what will be my mid value? Mid value will be 4. Now we will count for this 4. If we will count for this 4, I will get answer as 5, right? So when we get answer as 5, it is not satisfying our condition. Mid value was 4, and from 1 to 4 we are expecting 4 numbers only. We are getting 5 numbers, so we have to move on the left side, because we know that if count is not getting satisfied for 4, we will search for lesser number, as you have seen here. When count was satisfied, we are moving to right side. When count is not satisfied, we are moving to left side. So how to move to left side? So left will be same, and my mid value will become, sorry, right value will become mid minus 1, which is 3. Now here if you will see, left value is crossing mid value, so we will stop here. Now left is greater than 3, so we will stop here at this place. So whatever is my left value is, this is my answer now. So I hope this is clear for you all. So first we have checked linearly for 1, 2, 3, 4, and same thing we are doing for binary search. Now if we have to implement this function, how we can implement this function? So let's write here int, let's write the function name as solve, and let's take nums array. Now we will take left is equal to 1, we will take right is equal to length of nums minus 1. So this length I am writing it is in Java language. So in arrays length we find by nums dot length. Now we will go for the condition. What was the condition? Until unless my left was smaller, I was doing this iteration. So I will write left less than equal to right. I will find mid value. Mid value I will directly find by left plus right by 2. Now for this mid value we have to check the count, right? So we can call this function directly. So we will call this function. Now how to call this function? So can I write here, if count of nums comma mid, if this count is greater than my mid value, means for this case you can see for 5 this count was greater, so we are moving on the left side. Moving on the left side means moving my right pointer. So can I say that in this case I will move my right is equal to mid minus 1. Else what we will do, simple thing, if count is satisfied we will move on the right side to find the element. So else part can I write here, left is equal to mid plus 1. Once this while loop is over, so can I say that I will return my left. So this was the approach without modifying the array. So time complexity of binary search is log n. But every binary search, every time we are searching, we are calling this function, and time complexity of this function is big O of n. So can I say that my overall time complexity for this code is nothing but n into log n. N is for count function, log n is for binary search, and space complexity we have used here is constant, and we have not modified the arrow also. The given array we have not modified. So this condition, this method means satisfies all the questions, all the conditions given in the question. I hope you all able to understand all the approaches here. So hope you all will able to code this. Meet you all in the next video. Bye bye all.